Good morning. Welcome back. Today our discussion will continue from the last topic, the mole. And this is the third part of this series, the mole 3. If you haven't watched the first and second part, I would advise you pause this video and watch them because it will help you know what we are doing here. The mole 3 is all about the relationship between mole and volume. The relationship between mole and volume. Remember, we said that a mole contains a particular amount of substance, a particular amount of particles. And a mole also weighs the molar mass of a substance in the previous video. So today, we're talking of relationship between mole and volume. And at STP, that is standard temperature and pressure. At standard temperature and pressure, 1 mole of any gas occupies a volume of 22.4 dm3. At standard temperature and pressure, 1 mole of any gas occupies a volume of 22.4 dm3. For instance, 1 mole of oxygen gas at STP occupies the volume of 22.4 dm3. That is to say that this is 1 mole of oxygen in this container. And the space it occupies is from here to here, which is 22.4 dm3. Assuming from here to here is 22.4. Okay? So 1 mole of oxygen gas occupies this space, which is 22.4 dm3. 1 mole of carbon dioxide at STP occupies this space, which is 22.4 dm3 volume. So no matter the gas, as long as it's 1 mole at STP, it occupies the same volume. So relating this to our former discussion, it means 1 mole of nitrogen, for instance, 1 mole of nitrogen gas contains 6.02 times 10 to the power 23 molecules and weighs 28 grams because the molar mass of nitrogen is 28 and occupies a volume of 22.4 dm3. Just like you know that the molar mass of oxygen is 32, it weighs 32, which is mass of 1 mole. And 1 mole of oxygen contains this number of particles, 6.02 times 10 to the power 23 molecules of oxygen. And the space this particle occupies is 22.4 dm3 volume. 1 mole of carbon dioxide, the mass of 1 mole of carbon dioxide is 44 grams. And in that 1 mole, it contains 6.02 times 10 to the power 23 molecules of carbon dioxide. And the space it occupies is 22.4 dm3. So don't get them confused. 1 mole of sulfur oxide contains the same amount of molecules and weighs the molar mass, which is 64 grams. But the volume it occupies at STP is 22.4 dm3. 1 mole of oxygen gas contains the same number of molecules, which is 6.02 times 10 to the power 23 molecules of chlorine. And it weighs the molar mass, which is 71 grams. The molar mass of this chlorine is 71. And the volume it occupies at STP is still 22.4 dm3. Because 1 mole of any gas at STP occupies a volume of 22.4 dm3. Okay? So let's see how you can use this information in calculation. What is the volume of 0.2 moles of hydrogen gas? This is the question we are going to attempt. Remember, 1 mole of a gas at STP occupies the volume of 22.4 dm3, right? So that means 1 mole of hydrogen gas occupies 22.4 dm³ volume. So 0.2 mole, which is from the question, will occupy Y. Let's assume Y is the volume we are looking for. We occupy Y. Okay? From here, to find Y, you cross multiply. So Y equals to 0.2 times 22.4, which will give you 4.48 dm³. Therefore, 0.2 moles of hydrogen gas has a volume of 4.48 dm³. Okay? Alternatively, we can still use the formula method, because this one is the proportion method. We can still use the formula method. N, which is amount, equals to volume of the substance over molar volume, which is Vm. N equals to V over Vm. N is amount, which is number of moles. Then V is the volume of the substance. Then Vm is the molar volume. Molar volume is this volume of any gas at STP, which is 22.4 dm³. So from the question, we have number of moles, which is amount, N, as 0.2 here, and molar volume as 22.4 dm³. Then the question says, what is the volume of 0. So V is what we are looking for. So from this formula, making V, this V, the subject of formula, when you cross multiply, you have V equals to NVM. NVM. That's N times Vm. So V equals to 0.2, which is N, times 22.4, which is molar volume. So V equals to 4.448 dm³. Okay? I hope you understand. Alright. Let's try one more question on this. What is the volume of 3.2 grams of oxygen gas? Assuming that the molar mass of oxygen is 32, the molecular mass. This time around, they gave us mass and asked us what volume will this mass occupy. So, the first step is to relate mass and mole. So, first step, find the mole of 3.2 grams. Since 3.2 grams is what we are given, we have to find the amount of 3.2 grams. So, using this formula from the previous video, I hope you can remember this formula. We have N is what we are looking for. The amount of this mass is what we are looking for. So, N equals to what? When W, which is the mass given, is 3.2 grams, and M, capital M, the molar mass of oxygen is 32 grams per mole. So from this formula, M will be 3.2 over 32. So amount, which is N, equals to 0.1 mole. Amount is 0.1 mole. Okay? So now that we know the amount of the substance, the second step now is to now find the volume occupied by that amount. Because 3.2 grams has mole of 0.1. So the question is, what volume will this 3.2 grams occupy? So from this formula, N equals to V over molar volume. We are looking for V, and our mole, which is amount, is 0.1 from here. So 3.2 grams has the amount of 0.1 mole. Okay? Then the molar volume is 22.4 dm³. From this question, we are looking for V. So V as usual equals to N times Vm, cross multiply. So V equals to 0.1, which is N, times 22.4, which is the molar volume. This will give you 2.24 dm³. Therefore, 3.2 grams of oxygen gas occupies a volume of 2.24 dm³. I hope you understand. Good. I believe with these examples I've given, you can solve this study question. So I advise you pause this video and try your hands on these two questions. And you tell me what you got. If you have any question, you ask me. Thank you for listening. Bye!